Hey everyone, the Networkberg here. I hope you've been doing well. Apologies for not making any videos recently. I've unfortunately been busy with a house move, and I'm sure if you've moved house before, you know how time consuming that gets. Anyways, I'm not going to make any excuses. I'm still back. I'm going to make all the videos that I need to, and we'll continue with our Let's Lab This, which we'll do now. It's going to be pretty cool. So I'm just going to remind people to subscribe to the channel, like and share the video if you find any value in it, and let's get into the second Let's Lab This. So we've got our topology here, and the last time we connected a bunch of different routers, we gave them all intranet, and I had some issues with this FortiGate, which I think was just something where I needed to reboot my server, but now that that's been sorted out, I'm just going to remove one of these links. I'm fairly certain it was the Ether5 link. Let's just confirm. Did I give this a password? I think I actually did, yes. So, show system interface. You should see I did give it that 172 address. Okay, so the port 3 I need to remove. I just want to see if I can ping across it now. Execute ping 10.0.0.13. Yeah, it's working. Cool. Okay, cool. I can actually remove the... No, I'll keep it there. I'll keep it. Let's keep both links there. Let's say it will be a redundant link in the future. So it's not an issue. We'll keep both of them. We'll figure it out. Alright, cool. So we've got our topology open. I actually wanted to think a bit further than just the cloud. Because we discussed this could be our internet, like our service provider. What if we were the service provider? What if we were this cloud? What if there's more routers than this one that we're seeing inside this cloud? And that is generally how it works. I mean, you connect to your ISP and they have so much happening in the background with their routers in the cloud that you can't see, that you don't understand. And they're doing stuff to make your traffic faster. They're doing stuff to maybe rate limit some stuff. It's really interesting to see what happens on an ISP backbone, and we'll touch on that quickly. I mean, we're gonna build a little ISP. So instead of just assuming that we're these remote sites, these branches or home users, we are now actually going to become the ISP. So I'm going to just extend this view a little bit, and I'm going to move all these nodes somewhere else, and then this cloud's gonna go, see ya. It's gone. And I'm just going to delete the internet node for now. We'll put it back. I just want to quickly add a couple of more routers. So these routers I'm going to add is going to be, it could be a mix, but I'm just going to start off with some MikroTik routers. They're quite nice and easy to configure, so I like playing with them as a backbone. So let's add, let's say 3 of these. And let's give them 8 ports. And that should be fine. So I've got 3 extra MikroTik routers, and they are actually going to be inside of our core. I'm going to add these routers in different positions, because what I want you to understand as well is these is the provider network. So that cloud you saw where this router was in, that was the provider's network. So we're going to be a provider now, and we're just going to move the cloud a little bit somewhere else, and that is going to be the intranet now. So let me bring back that node to my management NAT. Let's maybe hide it behind there. Well, let's just connect the cable first. So let's do this. Ooh. Okay, come here. There we go. Ether 1, that's fine. And then let's collect these routers. And what I want you to imagine as well is this one router at the edge, which we'd call a provider edge, it has all of these customers connected to it. These other two routers, it could do the same thing. It could also just be provider edges connecting to different regions or cities. So I want you to remember that. A provider network scales remarkably big and large, and it has the job of just connecting a lot of different people to them. Okay, so let's start up our routers. And let's hide that, because that is going to be our internet now. There's the internet, woohoo! And I might just make some text here and call it internet. Make that a bit bigger. Little bit bigger, let's make it like that. That looks good. Okay, let's just bring that to the front as well. Cool. So we've got internet cloud there. We've got our MikroTik. This would be actually a provider edge as well, because this is also connecting to a different router. Like the only time that you have not a provider edge, just a provider router, is when it's a router that's connecting to just inside the provider network. So that would be these two routers at the moment, the MikroTik 20 and 19. So I just want to configure them quickly, because what I want to do is we're going to have this provider network, and then we're still going to have internet breakout from all of the sites through the provider network. If I remember correctly, we've got static routes configured, and all these sites can get to each other. And we're going to leave it like that for now. We just want to focus on getting them all connected to this MikroTik, and then from this MikroTik it will connect to the rest of the provider network, and it will break out to the internet. So let's just start configuring our provider network. And we need to make sure that we add our links in a specific range as well. So I am going to use the following. Let me just log on to this MikroTik. There we go. And then I just want to enlarge this a little bit again. Admin blank. Let me just close there. Okay. So, Ether 1 and Ether 7, we need to give IP addresses. So I'm just going to give this something in let's say the 10.0.50 subnet. That will be my WAN addresses or my LAN addresses between my routers. So let's use that. IP address, add address 10.0.50, and then .1 can be this router. And let's just give it a /29 to be safe if we want to do something cool later, maybe VRRP or something. And interface will be Ether 1. And I'm going to do the similar thing for Ether 7, but this IP address will be 5, and then Ether 7. Cool. So let's configure the other two MikroTiks. Actually, all three of them we're going to do now, because the cool thing we're going to do is we're going to set up Ospf now, so that we can learn all these routes at the remote sites inside the provider network, and that's going to be really fun. So let's admin. This is just one thing I find I need to do with the MikroTiks when I use the HTML5 console. You just close the window after you log in, and then it works fine. So IP address add 10.0.50. Okay, so I'm in MikroTik 20, so .2/29. I made a big mistake. Hang on, let's just fix it with our other MikroTik. So what I did was I wanted to give it /29s, but in my head I was still using /30s for the subnetting. So it means that these addresses are actually in the same network. So I just want to remove that quickly. So IP address set address 10.0.59/29, and that will be for number 7. Okay, cool. We're good again. Now let's do the same here. This will now become, it can be .2, Yeah, that's fine, but we need to /29, that's fine. Interface ether2. Let's just see if we can ping across quickly. We should be able to. 10.0.51. Interesting. Okay, let's just continue adding our IPs quickly. IP address, add address 10.0.50 dot. Let's make this dot 16, so let's make it 17. And then that interface is ether1. And I'm going to do the same on MikroTik 19. So on MikroTik 19, we're logging in. And let's quickly add the addresses here. IP address, add address 10.0.50. And let's make it dot 10/29. That goes into ether2. And then IP address 10.0.50. So 25/29 interface ether1. Okay, and then one more MikroTik, the MikroTik 18. We're just giving them addresses so that they can communicate with each other on the LAN. Let's just quit that. Reopen it. And let's see here. IP address print. There's going to be nothing. I was hoping actually that the HTTP would give this router address, but it's fine. We'll statically assign it. So let's do that as well. IP address, add address 192.168.246.101 /24 interface ether1 IP route 00 destination, and our gateway will be 192.168.246.2, which is our NATed address on Eve. So with this I should have internet breakout, which I do have. Alright, cool. So let's just add the last addresses. IP address, add address. On ether2 it was 10.0.50.18/29. On ether2, and then the other side was 10.0.50.26/29 interface ether3. Alright, cool. So we've got LAN addresses between our routers. So technically this MikroTik would be able to ping these two. This MikroTik would be able to ping those two, but this MikroTik at the edge where the internet is, it will not be able to get to the bottom MikroTik or any of the remote sites because it's not learning any of those routes yet. If I look at the routing table of MikroTik 18, it's going to be pretty barren. But if I look at the routing table of this MikroTik, it's not going to be barren. It's actually going to be quite a few addresses because we're statically routing some stuff and it's learning all of the WAN links, like the WAN addresses. So let's quickly get this learning. So when we're dealing with Ospf, there's a few things that I want you to use as baseline. You don't need to do this, but it is very good to do it. It's best practice almost. Just to always make sure that when you set up the Ospf, create like a loopback address, give it a address specific to that router, and then make your router ID on the Ospf that loopback address. It's pretty useful to make sure that there's no weird funny stuff happening if there is issues on the network, so it doesn't just crash your whole network. It's just a precaution. It's nothing, you don't have to do it, but do it. It's pretty good to do it. So I'm going to configure Ospf first on this provider edge router, and it's fairly straightforward on the MikroTiks to configure this. So it's routing Ospf instance. There's always going to be a default instance. If I print this, you'll see there's a default instance. It will always exist on the MikroTik routers, as well as a BGP instance. So let's just tweak this default one a little bit, because we're going to make this our backbone. So routing Ospf instance set router ID. I'm going to set this router ID as 4.4.4. You'll see in a second why, because I'm going to make the loopback address that. And do I want to do anything else here? Not yet, I'll show you when we do it. Okay, let's just set a router ID, it's fine. And then let's add that loopback address I was talking about. So to do that on a MikroTik, it's quite straightforward. You just add a bridge interface, and we call it allo0. That's just loopback address 0. If you're like into Cisco, that should look similar. And then IP address, add address 4.4.4 on the interface allo0. So now that loopback address is there. Let's do the same on the other MikroTiks. So MikroTik 80, I'm going to make 1.1.1. So interface bridge add name equals allo0. IP address add address 1.1.1. Interface allo0. That looks good. So MikroTik 19. We can make that one. I like working from left to right, so let's make that one 3.3.3.3. So interface bridge add name allo0. IP address add address 3.3.3 on allo0. Last one, interface bridge add name allo0. IP address add address 2.2.2 interface allo0. Alright, cool. So we've got our loopback addresses on all of the routers configured. Now let's make some Ospf magic happen. So we can do this by just typing, well, we've already set the router ID on this router, and on MikroTik it's pretty straightforward. The moment you add the network, it's going to pick up automatically which interfaces the Ospf needs to run on, and then it will automatically start to broadcast hello messages and try and connect. And if there's any neighbor that's running Ospf, it will connect and we'll be good. We'll be very good. So let's do this. Let's go into our routing Ospf network. Let's add a network, and we're going to add our LAN network addresses we added because we want to form the Ospf between these routers on our core network, on our provider network. So I'm going to add them there, and the network I want is 10.0.50.0/29 because that is the Ether1 interface. Ooh, and backbone. And we're going to do the same for the other one, and that was .8. Alright, so I've got Ospf configured on those two interfaces, and if I look at my Ospf, let's say interfaces, and we print that, we'll see it dynamically created two Ospf interfaces, and it is broadcasting. I probably just want to change that to something else like point to multipoint, but for this we'll leave it as broadcast for now. It's not going to be an issue for this lab. So we've got our two interfaces, but if we look at our Ospf neighbors, Ospf neighbor print, it's going to be blank because we haven't configured Ospf on either of these routers or any other router yet. So let's quickly form a relationship with MikroTik 20, and we can do that by just doing the same, doing exactly the same. So we're going to go routing Ospf instance. I'm going to set my router ID as 2.2.2, and then we're going to go routing Ospf network. Routing Ospf network add, and then the network we want to add is 10.0.50.0/29, as well as 10.0.50.16/29. This area I'm typing over the backbone, that is 0, area 0. That is the area that's supposed to like learn all of the routes. That will be your provider networks area, or your starting area. You can add additional areas in Ospf the more your network grows. Why would you want areas? Well, there's an Ospf video I've made that covers what Ospf is and what it does. So I'll put a link in the description for that. But a brief rundown is, you don't want your area to become too flooded with all of the Ospf traffic, because if you start having, let's say, 1,000 routers, it's not going to work. If you have 1,000 routers in the same area, it's going to cause a bit of hassle. So if you split it up in different areas, because Ospf sends everything through the whole network. So if you split it up in, let's say, 2 different areas, well, if it's still 500 routers, it's still too many. But let's say you had 200 routers. So if it's 100, that's not as bad. But if it's like all the routers just constantly sending each other messages, it's not going to be good. Alright, so we've set up the networks. So what I want to do is just quickly see, is the Ospf working? So routing, Ospf, interface, print. I've got my interfaces. So now the real question is, do I have a neighborship with anybody? IP, no, routing, Ospf, neighbor, print. I still don't have a neighbor, and I'm actually fully expecting a neighbor. There we go. There you are, Mr. Neighbor. So I can see the neighbor on this router, but not the other one. So I find that quite interesting. Oh, but it's still trying to initialize. Alright, so I think I know why it's not connecting, and I recall we couldn't ping that address earlier, 10.0.51. So it's not able to actually establish communication between these 2 routers. So on emulators, I sometimes find if you just swap the cable, that tends to fix it. Let's see if that's going to be the case here. So let's see. I've taken out that cable. I'm going to reconnect it. That looks good. And let's see if I can ping across now. I still can't ping across. Alright, I'm going to try one more thing, and that is going to be restart. Well, not one more thing. It's going to be a few things, but this is what this labs are aimed at, is us running into crap. And this is one of those instances which sucks, but let's fix it. So I'm just going to restart this routers, see if that brings it up. And if it does, awesome. If it doesn't, then we got a little bit of an issue, but not too much. I think if we just restart the actual VM, it should fix that. Let's see. Admin blank, admin blank. Let's see, ping 10.0.51. No. Alright, so what I'm going to do is I'm just going to restart my Eve server. So let's see after the restart if that fixes it. I'm just going to come here, root Eve, reboot -H, no. And now Eve's going to be like, what the hell did you do? Why's everything off? So I'll probably have to reopen my Eve page, or I'll just refresh it once it's connected. And then we'll see. And then hopefully that address is able to communicate. Okay, we're almost there. Living on a prayer. I should probably not be humming anything. I hear they demonetize you if you like whistle a song even. It's quite crazy. Not that I've got videos that's monetized, it's just get copyright claimed because you like whistle a tune or something. Alright, my server's back up. Let's reconnect. And all my stuff's down. Oh no! Oh no! Okay, let's start up our routers again. I at least want to get an Ospf working before we end this lab off. Alright, so our routers are starting up, our switches are still busy, but I'm not too concerned about the switches. I just really want these two routers to talk. If you guys can talk, that would be great. That would be great. Okay, let me just log back in, because I think I didn't log in properly. Is that what happens? That's what happens if you just like restart Eve and you come back in. Okay, so our routers are up. This one might still be starting, so I just want to see if I can ping it yet. IP address print. Alright, I need to close the windows again. Okay, ping 10 0 52 1. And ta-da! Ta-da! And you see, that's the point I want to stress, is you might work with emulators, and trust me, this happens with all the emulators. You might be on a good path, and then something like that happens, and you spend more time troubleshooting why it's not working than just doing something simple like swapping the cable or restarting the server or the nodes, because that can fix it. That can definitely fix it. I don't know why that happens, but I've seen it happen, and it's happened with most of the emulators I've seen as well. So it's not something that's strange. Just maybe if you see something like that yourself, do this as well, else go troubleshoot to your heart content. But since it's not something with the actual configuration, you're probably just going to knock your head against the wall, and you're going to get very frustrated because you're not going to fix the issue. Alright, so in theory I should actually have my Ospf connecting now. So let's check routing Ospf neighbor. Hello neighbor. Hello neighbor. Alright, cool. We've got our neighborship and it is full, and we can see we're connecting to 10.0.50.1. There's our router ID. So the Ospf relationship has been formed between these two routers. Let's quickly configure it between the other two routers. I just want to do my little trick and close that, open it. Alright. And since I've moved, I apologize. You hear like these big angry birds that just like are shouting. I don't know why. I might move when I make the videos from the morning before I go to work to the evening or something, just so that I can not make that an issue. So apologies if you've been hearing like that bird. But I do love birds though. They're amazing animals. Alright, so MikroTik 19. I don't think I've configured anything on you yet, but let's do it. Routing Ospf. Instance set router ID. This one was 3.3.3 for the default. Routing Ospf network add network 10.0 50.8/29 in the backbone area, and then there was a 24 in the backbone area. So let's go back to this MikroTik. I should in theory now have two neighborships on this router. Routing Ospf neighbor print, and I do indeed have two neighborships, which is perfect, because then these two routers, like MikroTik 20 and MikroTik 19, is able to exchange routing information with the MikroTik here at the edge. We will rename them as well. This will be our provider edge. This will be provider routers, which we will convert to provider edges later on. And this will just be our, people call it an ASBR. Just think of that as the thing that gets out to the internet. So that's what that is. I just need to configure this MikroTik now, and then we can start to actually learn the routes across the network, which is going to be cool. It's really cool to see it happen, and you're with me to watch it happen. So let's set our Ospf router ID, Ospf, instance set router ID 1.1.1 for the backbone, and then routing Ospf network, add, our network will be 10.0.50 dot 16 and 24 in the backbone. And there we go. So if I go routing Ospf neighbor print, we've got full relationships with all our routers. So all our routers on our provider network is exchanging or able to exchange routes. So there's one more thing that I want to do now, and that's show you how we're going to be learning routes. So we're going to do this in two ways. We're going to manually define it, and we're also going to redistribute some routes, because why make life hard? Why do you want to keep adding manually all of the addresses when you know nothing's going to change? There's nothing weird going to happen. So I'm going to show you how to do both. First thing that we're going to do is on MikroTik 18, which is the one that faces the internet, I want you to see IP address print. So this is where 1.1.1.1 is, right? If I go into, let's say, MikroTik 20, I do an IP route print. It's not learning that address. It's not learning any address, actually. Same thing on this PE of ours. So IP route print. It's got a bunch of other routes that we've statically configured, and it is learning about these other routes now behind the neighbors, which is great. But I want to, what we're doing is essentially the same thing, and it's the same commands we're running. Nothing's changing. But as long as the network exists on the network or on the node, on the router, if there's a static route for it, you can advertise it across the network. And we're going to do this now by going into MikroTik 19 or 18, sorry. That's the one that's at the internet with the address 1.1.1.1. I'm going to say routing. Again, same commands. Routing Ospf network, add network 1.1.1.1 on the backbone area. So let's go on to this PE MikroTik. If I do an IP route print, you see there's no 1.1.1.1 there, but we got it now. We're learning it, and we're learning it from two different sources. How freaking cool is that? So now we've actually got redundancy as well. In case, let's say, one of the routers go offline, it will follow a different path to get to that subnet, to that network. How cool is that? I'm going to do the same now for the rest of the core network or the provider network by just adding these addresses. Alright, so let's go on to MikroTik 20. Come here, mouse. I've lost my mouse. I found it again. Routing Ospf network add, and the network we want to add is 2.2.2, and it is for the backbone. And don't worry, I will show you more about different areas as well later on. I just want to set up the core network now, and then do the same on MikroTik 19, routing Ospf network, add network 10, no, that is 3.3.3 on the backbone. And last but not least, our little provider edge. And from our provider edge, I'm going to add the same, routing Ospf network add network equals 4.4.4 for the backbone. Awesome. So if I do an IP route print now, I'm going to see all these different networks, 2.2.2.2, 3.3.3.3. So I'm learning all of these networks now between my core infrastructure, which is pretty good. But the question now is, and it's a it's a big question, will my remote sites that I gave internet to previously when there was just the ISP there, will they have internet? Let's quickly check. Let's see. I'm going to close these windows. And then I'm going to go into MikroTik 15. Because we had internet before, I know that. But do we have internet now? And I'm pretty sure I know what the answer is. But let's test that theory. And no, we don't have any internet. I've got static routes configured out to my next hop, which is the PE. So all of these routers will be able to connect to this MikroTik. But what we need to understand is now on this MikroTik, if I do an IP route print, there's a default route configured. But this is legacy. This is what we had configured before. So I actually just want to remove this default route, IP route remove. I'm going to remove it. And then there's a few other configurations I want to remove. I think it's just my IP firewall NAT. I just want to disable that NAT. Okay. So if I do an IP route print, I don't have a default route now, or route. And if I do a ping, I know it's still going to fail. Like it's getting to 10.00.17, which is this MikroTik, but it's not able to break out. Reason being, we don't have a default route to get out. And there's no way for MikroTik, like the ASBR, the MikroTik at the edge connecting to the internet, to know about these IP ranges. It doesn't know how to get back. There's no return traffic. So this is what I want to show you now is, let's first advertise a default route to the rest of the network. So that default route we're going to configure, and it's going to be sent to our provider routers. So let's do that by going into MikroTik 18 and then routing Ospf instance set, and then there is a default distribute default, and we're going to distribute that always as type 1. You can think of type 1 and 2 because there is a type 1 and a type 2. You can think of type 2 as the less preferred route, so don't stress too much about it. I'm just going to use it as always as type 1. And we're doing that for the default Ospf instance. Now what do you think is going to happen? Because we are redistributing routes now. It's just a default route we're redistributing. So if I go on to MikroTik, the PE, if I do a route print, whoa, trippy. I've got a default route now, and I've gotten it from my 2 neighbors as well. So again, if one of the neighbors dies or goes off, I'm able to just transit over the other neighbors. So that's quite nice. So we're sending out the default route, but do we have internet access yet? No, we don't. And again, it's that point I made, we don't have a way to get back to these addresses. So we can fix that quickly by just going onto the PE, and what I'm going to do is routing Ospf, because I want to redistribute. I want to tell this MikroTik to tell its neighbors how to get to all of my connected networks as well as my static networks. So routing Ospf instance set redistribute. We want to redistribute connected, so we're going to say yes, or always, or where is it, as type 1. And let's also redistribute our static. That looks good. Probably shouldn't have 2 equals there. There we go. Now, for the good part. If I go onto MikroTik 18 now, and I do an IP route print. Whoa, that's so cool. It's learning all of my networks. I can see all of the networks now. So it's also got dual routes to get back to my WAN links and my LAN links as well, which is pretty awesome. So I'm actually going to make a good bet now. I'm going to say I should be able to ping out to the internet, and I still can't. So let's quickly see why. If I run a traceroute, tool, traceroute, I actually think I know what's wrong, and it's nothing to do with the config there. Remember that NAT rule we had at this MikroTik, we just need to move it to this MikroTik. So MikroTik 18, because the thing is, when it's going to the internet now doesn't know how to get back to our networks. So IP route, IP firewall NAT, add, source, chain is a source NAT, out dash interface is ether1, and our action will be masquerade. Okay, I actually think this will work now, and there we go. So we've got access now to the internet from our remote sites over our provider network. Really, really cool. And if I run a traceroute, let's just see. Yes, it's actually going out to the internet now. So we're pretty good there. I'm going to close off these windows. And before I close off the lab, because we are running out of time now, I just want to add a custom shape. And this is nothing, this is just to make things look a little bit neater. So let's make a circle. And let's dash it, and let's make it maybe like a very nice light blue. Very nice light blue. This will be our circle for our Ospf instance that we added. And let's just move that here. Cool. We can maybe clone this text and call this area 0. Awesome. Alright, cool. So we've got Ospf configured. We've got a provider edge there that connects to these remote ends, these endpoints, these homes, these offices, whatever you want to think. It could even be other ISPs, but preferably not. We'll discuss peering a bit later. But there we go. We've got a backbone area here, and we're learning routes across the network in order to break out. So I'm gonna call the video here. I'd like to thank you for watching, and I'll catch you again next week for the next Let's Lab This. Hope you have a great week. See ya.